Okay, Ethidans, this is our last video for this topic, and we're looking at solving trig equations. And so I've got two examples to get through here. Okay, here's our first example asking us to solve this equation. Before we go solving it, I'm going to sketch what this equation looks like. So we're doing sine x, and if we look at our transformations, it's going to be transformed up by 2. So instead of starting at 0, 0, it'll start at 2. And it's also been stretched by 3, so it'll have an amplitude of 3. So we'll put in our points that we're going to sketch. Oops, I need to put that one down here. And there we go. So I'll sketch those points in as carefully as I can, which is never particularly easy. Okay, so that's my graph of y equals 3 sine x plus 2. And then if we're solving it for 1, well, the line y equals 1 would pass through like this. That would be y equals 1. And so if we're solving for where these two graphs are equal to one another, they're actually going to have two solutions between 0 and 360. And so we just need to be mindful that when we're solving this, we're getting two solutions, and both of those solutions are going to be between 180 and 360. So let's start solving this by subtracting 2 from both sides. And so we'll get 3 sine x equals negative 1, and divide both sides by 3, so sine x equals negative 1 over 3. So this is where we use our sine inverse. So you remember this from year 11. So we go x equals sine inverse negative 1 over 3. Now the question is asking with an interval in degrees, so when we use our calculator, we've got to make sure that's in degrees mode as well. So the first thing we'll do is put that into degrees, and then we'll go sine inverse negative 1 over 3. Okay, so then we get negative 19.4, we'll write negative 19.5. So you get x equals negative 19.5, and we can see that obviously that is outside of our range here. So what your calculator is actually doing is solving for the first or the closest value to the origin. So if we continued this backwards, in effect it's solving for this thing here. So what we have to do is employ the symmetry of these graphs and realize that the distance between there, which is 19.5, is going to be the same as the distance between 180 and where it crosses. And so we could add that amount to 180 to get our first solution. So that would be 199.5 degrees, and that would be our first solution. To get our other solution, we would subtract that distance from 360 using the symmetry of a sine curve. And so 360 minus 19.5, that would be 340.5 degrees. Now that's not the only way you can solve it. You can actually use your calculator to graph and solve the intercepts as well. So let's have a look at how we could do that. So in one graph, I'll just bring up the example again. So in one graph we'll put the left hand side of the equation, which is 3 sine x plus 2, and for the other one we'll write 1, which is the right hand side of our equation. Now I'll have to make sure my viewing window is similar to what I've graphed here, so I'm going to get it to start at 0 and finish at 360 because we're operating in degrees, and the y min will go negative 2, and the y max will go up to 6 to make sure it's all incorporated. So let's graph it, see what we get. Okay, so you can see we've got a similar graph to what I've drawn here, and so we're going to press G solve, which is F5, and that intersect button will find the intersect of our two graphs. So we'll press that again, which is F5, and there's our first intersect, 199.5, which is our first answer we got. And we press this arrow key to get our next one, and there we go, 140.5, which was our other answer as well. So I just wanted to show you this whole way so that you get an understanding, but realistically you would probably write down this far if you're doing this in an assessment, and then you'd get out your graphing calculator and graph it. Okay? Alright, question 2, we're going to do the same thing. We're going to sketch out the cos graph, and then we'll draw a line that represents -3 over 2. Now this time we're in radians because we're going between 0 and pi. So the cos graph will go through these points. So I'll put the points in so I know where I'm going to be sketching. And it'll look something like this. Okay, so that's y equals cos x, and -√3 over 2, that's approximately 0.86. So that'll be a line going through somewhere like that. So that's y equals -√3 over 2. So you can see that across this interval we're going to have two solutions, one a little bit less than pi and one a little bit more than pi. Now √3 over 2 should also be ringing bells because that's an exact value, so you can make a triangle out of it, remembering that cos is adjacent and hypotenuse. So if that's our angle, then 2 would be the hypotenuse, √3 would be the adjacent, and 2 squared minus √3 squared, which is 3, square rooted, would give us the other side. So that's 4 minus 3, which is 1, and the square root of 1 is 1. And so if we're trying to work out what angle would give that, it's going to be a multiple of whatever angle this is. And if you go to your formula sheet, you'll find a triangle like that, which is this one here, and we find the two angles of the triangle are pi over 6 and pi over 3. So the shallow angle is pi over 6, and the wider angle is pi over 3. So if we were trying to work out what angle would give you this ratio, it would be pi over 6. Now the thing is, that would give you the positive angle way up here, so you know, something like that. But you'll be able to use the symmetry of trig graphs to realise that the distance between here is going to be the same as the distance between here. So our first solution is going to be pi over 2 plus pi over 3, which is going to be 5 pi over 6. So that's our first solution, and using that symmetry again, we're going to realise that the distance between here is also going to be the same. So our other solution is going to be 3 pi over 2 minus pi over 3, and so that's going to be 9 pi over 6 minus 2 pi over 6, which is 7 pi over 6. Alright, so those are our two possible solutions. Now you do have access to your calculator, so might as well go through how we would use that. And so we'll put in our two graphs. So we've got cos x, and we've got -√3, and I'll put that in brackets just to make sure my calculator doesn't get confused. -√3 divided by 2. Now this time we want to be sure in radians, so we'll put us back into radians. There we go. And we'll have to change our viewing window. So our x max goes to 2 pi, and our y min max, -2 to +2, should do the trick. Okay, and there's our graph, and we can see our intercepts there, so we'll g-solve for our intercepts. Here's our first one, 2.62. So I'll just write that down and we'll check that in a minute, 2.62. And the other one is 3.67. So write that down as well, 3.67. And what I want to do is just check that we've definitely got our first questions right, because exact values are always preferable. So 5 pi divided by 6 equals 2.26, so that decimal, what that one is correct. And then 7 pi divided by 6 equals 3.67, so we know that that one's right as well. Okay, so I'm showing you both ways because sometimes we do need exact values, sometimes decimals are fine. You'll have to make that judgment call at some stage, but a good rule of thumb is if it's given to you in exact terms, give it back in exact terms, or if it's given to you in radians, give it back in radians. And I just realised now that it actually says give exact solutions, so we were right to do it this way in the first place. And so it's a good idea to sketch out the graph to get an idea of what's going on. Okay, the work that I've set for you is these two exercises here, and it's really important that you fill out your progression, so I know that you've watched what you need to, you've done the work that you need to. Please remember to fill out the exercise number there as well. Other than that, this is the last video, and so hopefully after this we can start to focus on our internal